In this video, I want to have a look at the sine rule and how we can use it to find an angle in a triangle. So this formula is on your formula sheet. So we've got in triangle ABC, A over sine A equals B over sine B equals C over sine C. And this is the way we were using it in the video where we looked at finding the length of a side. But because it's a lot easier when we're using formulas to have our unknown in the numerator, when we're finding an angle, we're going to flip these fractions upside down. So instead, we're going to have sine A over A is equal to sine B over B. So let's have a look at what that looks like. So in our first example, we're finding this angle up here, this theta. So we'll start by matching them up. So our theta is opposite this 18 here, and our 115 is opposite our 25. So those numbers are going to be paired up in our formula. So our theta, we want where this A is, just to make it a little bit easier to solve. So we're going to have sine theta over the 18 is equal to sine of 115 degrees over 25. So then we're trying to get theta on its own. So let's multiply both sides by 18. So our sine of theta is equal to 18 times sine of 115 divided by 25. And then to get the theta on its own, we need to take sine inverse of that side. So sine inverse of that whole fraction, so 18 times sine 115 degrees over 25. And when you pop that in your calculator, if we round it to the nearest minute, we would have 40 degrees and 44 minutes. So that's the size of that angle there. In this example, we're still trying to find this angle theta here, but we've specifically been told that our angle is obtuse. So that's going to add one extra step of working at the end of our question. But let's start off the same way. So our theta is opposite that 8.4, and our 30 degrees is opposite that 6.3. So we'll write sine of theta over 8.4 is equal to sine of 30 over that 6.3. So we're going to multiply both sides by 8.4. So we'll have sine theta is equal to 8.4 times sine 30 over 6.3. So then that means that theta will be equal to sine inverse of that whole fraction. So that whole 8.4 times sine 30 over 6.3. When you pop that in your calculator, if we round to the nearest minute, we would end up with 41 degrees and 49 minutes. But we were specifically told that we wanted our angle to be obtuse, and we've been given an acute one. So we know from our work with obtuse angles and sine that we need to find the supplementary angle there. So actually, our angle theta is going to be equal to 180 degrees minus 41 degrees and 49 minutes. Oops, sorry, degrees and minutes, which would be equal to 138 degrees and 11 minutes. So that there is the size of that obtuse angle. So that's a few examples of using the sine rule to find the size of an angle.